Hello and congratulations for completing our linear data structure. From today onward, we will talk about some non-linear data structure, and in that we will start with tree. So let's begin. Firstly, we will see what all objectives we will cover with trees. So firstly, we will define what a tree and its terminology. Then we will see where to use tree, and then we will compare tree with other data structure. After that, we will explain difference between trees. Then we will actually talk about different kinds of a tree which we have. And then we will focus on only some of the tree. So there we will implement operation on the binary search tree. Once our objective part is clear, let's begin with our first objective. That is what a tree and its terminology. So firstly, when we are talking about a tree is similar to the linked list, except that instead of each node pointing to the next node in a linear fashion, each node points to the number of nodes. And here, lists are linear, but tree is non-linear. And then in tree we can take many paths. So how it looks actually? So here our tree looks something like this. Here we have 8 which is connected to 3, then 1, then 6 and so on. So here a tree is similar to the linked list except that instead of each node pointing to the next node in a linear fashion, each node points to the number of node. So each node can point toward the number of node instead of just pointing towards a single node. And in tree we can take multiple paths. Once our concept or our definition of tree is clear, let's understand its terminology. Here we have root. So top node in the tree. So here our root node is 8. Then we have child, a node moving away from tree. So here 3. 3 is the child of 8. So node moving away from a tree. That is called child. Then we have something called as parent, the converse notion of the child. So here our parent is 8, although it is a root, but it is always the parent too. Then we have 3. 3 is also a parent of 1 and 6 and so on. After that we have siblings, a group of nodes with the same parent. So 1 and 6 both belongs to the same parent. So again 1 and 6 is siblings. Then we have leaf, a node with no children. That means 3 is having children 1. So it is not a leaf node, but 1 is not having any child. So it is leaf node. After that we have edge, the connection between one node and another. So connection which is joining 1 and 3 is called edge. Once our terminology is clear, now we are in a position to see the uses of the tree. So at multiple places it is used, but we will discuss only some of them. So when we are actually seeing the HTML DOM, document object model, so it is actually making use of tree. Then we have the network routing. If you will see the picture of network routing, then you will analyze or will be able to see that there is a concept of tree. The number of things are connected together. Then in AI and ML also the tree is used. Then we have folder in the operating system. There also we are able to see trees. Computer files. There we are able to see one file is connected to the second file, inside that some other, and so many things. So all these things are using trees. Then we have something called a JSON data. That is the best example of the tree. So with this thing, our some theoretical concept of the tree is clear. In our next video tutorial, we will actually talk about the type of tree. And there we will see many more concepts also. So let's meet in our next video tutorial, and please follow my complete playlist about data structure and algorithms to have complete understanding about data structure and algorithms. Thank you very much for now.